going on, guys? So today I'll be going over my first presentation in a new series on Intro to Machine Learning. Uh, Sort of an inspiration for this video and this video series. What I like to see, at least in my teaching philosophy, is that when there are those that teach, usually you should be able to teach and explain very complicated concepts uh, in such a way that even a young child can understand. So that's always been a big motivation for how I have learned in the past, where people can explain things very simply. And usually you only really know the technical and the overarching concepts when you can explain it in terms of the foundations and the fundamentals. So as an intro to a new series, we're going to go over an example of machine learning and sort of the idea of thinking like a machine and how we teach machines to learn. And it's very similar to how we would approach a situation. And we're going to do it through an example called Sally Wants to Go Outside. So the objectives of this presentation is to develop an intuitive understanding of how machines learn, so much so even a child could understand. Again, when we can understand the fundamental concepts, it's much easier to abstract those to larger, more complicated concepts. And intuitive understanding. So we're not here to just memorize terms as we tend to see in lots of other types of presentations and tutorials, but we want to have that intuitive understanding of, this is how a machine learns and can gather a few variables and refine those to make decisions. How is it similar to how we behave? And for the prerequisites for at least this presentation, I'm going to say none. Again, if I can explain it. Well, I should be able to explain it to a 5-year-old. So no prerequisites. All you need is an open, creative mind. So to give you a background on sort of this problem, we can imagine we have a girl named Sally, and here we have Sally in the bottom left. Sally enjoys playing outdoors. All right, just like a typical girl that's 10 to 12. But depending on the day, she either decides to go out and play or not and stays indoors. So she makes that conscious decision every day to stay home, to do all the fun things she loves doing at home, or to go outside and play. Like any other girl that's 10 to 12, the decision to go out to play depends on a few factors. So for example, in the center here, we have a television, what looks to be a notebook, and some friends. So the television is just there to represent the idea that Sally's favorite show might be on at any given day, right? So when your favorite show's on, you're more likely to want to stay indoors versus go outside. The notebook is there to represent homework. So Sally has homework that she's in charge. So it's during the school year. If she has homework, she's more likely to stay indoors. And to the contrary, we have things like her friends, where when her friends are there, or when all of her friends are there, she's more likely to want to go outside and play with her friends, versus when one of her friends wants to play, she's more likely to stay indoors because she doesn't have as much fun. And additionally, we can imagine the temperature and sort of the conditions outside. So on a sunny day, Sally loves going to play outdoors. On a cloudy day, she hates it. And one thing to look at when we envision this problem is that we're sort of making these assumptions about the sun and the rain, and she likes to go out and play in the sun and not out in the rain, but we really don't know what Sally's behavior is. Maybe she loves playing outdoors when it's raining outside, right? We don't know. So we can make some assumptions at the beginning, but in the end, we really need to test it against Sally's behavior. So as I said, the decision to go outdoors depends on several factors: whether or not her favorite show is on, whether or not she has homework, how many friends she has to play with, so that could be a number from 0 to 5, and additionally, whether it's sunny or rainy outside. All factors, positive or negative, we don't know. So we can look at one example of what Sally might want to do on a particular day. So we can look at the example of on Tuesday. On Tuesday, all of Sally's 5 friends are outside. So we can develop an intuition that on this particular day, chances are she wants to go outdoors. Secondly, she has no homework. That's good. And it's a sunny day outside. So we can ask Sally, do you want to go outdoors or not? And she'll say on this particular day, she wants to go outdoors. So we can look at the fact that she wants to go outdoors versus stay inside. And we can also look at the fact that, to keep it simple, we left off the example of the television. But we know, depending on her friends, homework, and the weather outside, whether or not she wants to go outdoors. So we can already develop a preliminary intuition for what she likes and doesn't like. And then on the contrary, on Wednesday, all of her friends, let's just say they have homework, so none of them are outside. Her favorite television show's on side, or her favorite television show is on, and it's sunny outside. So on this particular day, Sally is sad and she decides to stay indoors. So if we really want to know about Sally's behavior, we sort of can't look at some anecdotal examples. We need to look at her past behavior in order to develop that a better intuition for exactly what she wants to do. So, like I had said, there's some simple examples of sunny, friends, homework, no television. She wants to go outdoors. The second example sort of makes sense to us, right? Sunny, no friends, no homework, and television. And she decides to still stay indoors, right? So even though she had no homework, she still decided to stay indoors, okay? So we sort of, that's something that's changed. But for example, let's just say it's sunny outside. So she maybe is motivated to go outside. Only three of her friends want to go outside. She has homework, but her favorite television show is not on. So on this particular day, she decides not to go outside. So we can sort of see that, okay, well, it's a combination of factors. And it's a combination of factors where we actually don't know the relative weighting of what's important to her or not, right? So we sort of have to uh, make some predictions that we'll do in a few slides. So one way we can approach this is we can actually look at every single use case for what she wants to do. So we can sort of develop like a word web. So we can say for every particular sunny or rainy day, she either has homework or doesn't, favorite television show or not, or is on or not, and of course the number of friends she has can be from 0 to 5. So Sally's getting a little tired because she can sort of see how quickly this can become complicated. Not only that, but maybe we don't have examples of every single use case or every simple example for how many friends with every single example, if we only have evidence from the last month or so. So we can develop a web for every decision, but this gets very complicated. So this is not a very good way. We can't just ask Sally to go outdoors or stay indoors for every single possible use case, because that's not realistic in the real world. Well, what we can do is that we can sort of develop a table. So this just summarizes the information a little easier. Makes it much easier just to, from a bird's eye view, see what things might impact her behavior. So we can just see a few trends just from simply looking at the data. So I think the Monday and Tuesday, the Tuesday and Wednesday we've seen already, or I've maybe changed these examples slightly. But just as a general overview of looking at this table, we can see that there's only 2 days where she decided to go outdoors, which is the last column. She did it on Tuesday and Wednesday, and they just happened to coincide with the days that she had four or greater friends outside. So we can sort of see that in particular, friends tends to be a very good correlating factor with what she wants to do, just as a general look. Additionally, Sally only goes outside when she has no homework. Okay, so that's something that's very important for us to look at. So, for example, on Tuesday and Wednesday, the decision to go outdoors coincided with when she didn't have homework. Okay, so that could be the camel that breaks the back. Maybe it's something about the homework that when Sally has so much homework, she's just overwhelmed, and no matter what, she doesn't want to go outdoors. So that could be the case. So we're not quite sure based on just these 2 examples. So we can look at the other 3 examples to see maybe there's some relationships that correlate with her not going outside. So we can see that Sally sometimes goes outdoors when it's sunny, but not always, right? So on a sunny day, which would be the Monday and the Wednesday, she decides to go outside on Wednesday, but on Monday, there's something about Monday that, regardless of how hot and sunny it is, Sally does not like to go outdoors. Again, is it the impact of the homework? Is it the fact one of her friends is outside? Or is it the fact that she has, her favorite television show is on? We really don't know. So that at the top, those 3 bullet points are just the observations that we looked at on the last slide. So what we're intuitively doing when we're sort of doing this balancing act when it comes to what's important and not important is that we're sort of evaluating a set of weights and we're coinciding with the observations. So we can sort of say that sunny, give or take on some days versus other days, it maybe has an impact and maybe it doesn't. So we'll just put a positive and negative at the top of that column just to correspond to the temperature. Homework, additionally, we've sort of established that there potentially could be a very large impact of homework. So we're going to give a large negative weighting to homework, meaning when there's when she does have homework, which would be the Monday, Thursday, and Friday, it's sort of the big factor. So we'll assign it 5 negatives quickly. Friends, alternatively, because that's a number that can range from 0 to 5, we can sort of suggest that with a large number of friends, there'll be more positives. When it's 0, there could be no positives, or it could be a negative. So we really don't know. So that's a variable that we can play around with. And additionally, with the television, again, we're not quite sure. So we can assign that a positive and negative, just because from our limited number of examples, we really can't tell. So with that, we're approaching the 11-minute mark. So we're going to pause it, and then we're going to resume with our next part 2 of this presentation series. Thanks.